PowerPoint for today's lesson. The video? No. Well, it is as far as it's going to be on here.
How does the difference between 0.00000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What's the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and you need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Okay. So, logarithms, as it says, the logarithmic function is a way to rewrite exponential functions. And hopefully you caught how you put things around to get from a logarithmic function to exponential function. We're going to learn more about that relationship as we go through today. From the video, some things you can fill in. Base raised to what power equals the number n, if you will. For example, 2 to the third we said is 8. If we were to write this in logarithmic form, it'd be log base b of n equals p. That's the relationship between writing a function in exponential form and writing that exact same function in logarithmic form. Now I'm going to go over how I do this later on in the lesson. Right? That leads us then to what does the logarithmic function mean? And if you need to take some notes about how to say this, take some notes on how to say it. I've said for most of my career that I always want my students to sound as intelligent as you are. And if you read things incorrectly, people This is read. This is creed. So now I'm speaking correctly. Awesome. Log of base 2 of 8. That's the log base 2 of 8. And so the log base 2 of 8 is posing the following question. What power do I raise 2 to get 8? Answer B, 3. What power do I raise 10 to get 10,000?
4.
And then finally from the video, what power do I raise 2 to get 64?
6.
That is how the logarithmic function works. It is saying use this base. What power do you raise this base to get this result? Any questions on that or anything else in the video? TED Talk series is really, really excellent. Okay? So, find the value of x in each exponential equation, explain your reasoning, then rewrite the exponential equation as a logarithmic equation. So we'll just do a couple of these. Letter B. 3 to the what gives you 9. And so if I were to write that, if I were to write this original expression in logarithmic form, I would say the log base 3 of 9 equals x. Some of these you have to think a little bit more for, like 5 to the x. What power do you raise 5 or anything to get 1? 0. What power do you raise 5 to get 1/5? What is it? -1. And then finally, what power do you raise 8 to get 4? Does anybody think they know the answer to that one?
2/3.
Outstanding. How did you figure that out?
Because I just cubed it and then squared it.
So 8, raising 8 to a power to get 4 is pretty tough. But if we can take this 8 and get it down to 2, well, how do we get down to 2? We take it to the 1/3 power. Right? 8 to the 1/3 is 2, cube root. Well, then I want to take that result. I want to take that result, 8 to the 1/3, and I want to get 4 out of that, so I take that result and square it, 8 to the 2/3. I don't know that I've done an excellent job with this year, but in the last few weeks, I've been at times encouraging you to get used to writing numbers as the smallest number possible to a power. 8 is 2 to the 3rd. 16 is 2 to the 4th. 81 is 3 to the 4th. Things like that. Because that kind of thinking is going to help you as we go throughout this week. All right. As normal, what's the graph look like? We didn't start with the traditional, here's functions and here's graphs and match them up. Okay, we're going to more investigate this. Here's what we dealt with last week. Exponential functions. The most basic exponential function is 2 to the x. So if I start subbing numbers in here, 2 to the -2nd is what? 2 to the -1st? Thank you. 2 to the 0? 1. 2 to the 1st? 2. 2 to the 2nd? It turns out that logarithms are the inverse of exponential functions. So dig back in your brains from a few weeks ago when we discussed inverse functions. To come up with an inverse function, we said that we take the x's and y's of one function and flip them. That's how you find the inverse of a function, and that's the relationship. The relationship between exponential functions and logarithmic functions, they are inverses of each other. So if I take all of these points from this basic exponential function of base 2, and I flip them, Now I have data points from the logarithmic function. And it works. Let's start with the easy ones down here. If I'm taking the log base 2 of 4, and I'm asking, what power do I raise 2 to get 4? And the result would be 2. What power do you raise 2 to get 2? 1. What power do you raise 2 to get 1? 0. What do you raise 2 to get 1/2? -1, and to get -2, or be at 1/4 be -2. We've literally taken an exponential function and we've flipped all the x's and y's, and that's how you come to the logarithmic function. Now, I'm getting close to being done grading your chapter 5 tests. It has taken a long time. What does it mean that it has taken a long time? They're not very good. When tests and quizzes are really good, it doesn't take long to grade them. When they're not good, it takes a long time. Because I'm trying to be consistent about my grading and this many points off and this many points off and stuff like that. Okay? If I just went through and mark them wrong, grading doesn't take very long. I don't do that. I go through and mark them wrong, and I say, well, this person got this much for right. Did anybody else get that much for right? How many points did I pick off there? I got the same amount of points up here, and I try to be very equitable in my grading. They're not very good. Overall, they're not very good. Some people's are outstanding. Some people got over 100%. Some people got 50 out of 50, 49 out of 50, 48 out of 50. There were, 2 bonus opportunities on the quiz, and then there was 1 secret bonus opportunity on the test. So some people got over 100%. One of my biggest disappointments, probably my biggest disappointment, is that regardless of my emphatic pleading with you to memorize the domain and range of the basic pair of functions, some of you just never did. I mean, I got to the back of that test and I thought, you know what? Let's throw them a softball in the back of the test. We're going to have them graph a cube root function. And then I asked you, what is the domain and range of this cube root function? And I'm getting all this crap like x is greater than or equal to 3 and x is less than 4 and x is greater than 0. Folks, what's the domain of any cube root function? All real numbers. What's the range of any cube root function? All real numbers. I don't care what it is. I don't care if you're multiplying the function by something. I don't care if you're dividing by something. I don't care if you're adding. I don't care if you're subtracting. If it's a cube root function, the domain is all real numbers. So take that as encouragement today when I say memorize the domain and range of the basic logarithmic function as quickly as possible so that you don't make silly mistakes like that on an upcoming test or quiz. I told you multiple times, I said, guys, it's going to be to your benefit to get this domain and range memorized as quickly as possible. And some of you obviously studied, and some of you obviously worked hard, and some of you obviously blew the whole thing off. Okay? I want you to think about any generic, non-translated exponential function. What is the domain? All real numbers. What is the range? Y is greater than 0. My greater than or equal to just greater than 0, right? Well, think about the fact that we have just taken a generic exponential function and we flipped it. We have just exchanged the x's and y's. That should help you figure out the domain and range of this logarithmic function. All right, so I'm going to give you about 2 minutes. Take those points, put them on the graph. Write down what you believe to be the domain, the range, the x-intercept, and the equation for the asymptote. That's something new we're going to be talking about this week. Give me a couple minutes. Okay, so if I'm going to plot these points, at 1/4 I'm at -2. At 1/2 I'm at -1. At 1 I'm at 0. 2, 1, 4, 2. There's my graph. The domain and range are flipped. What do you believe the domain is for this generic logarithmic function? Greater than 0. The range of the exponential function was greater than 0. We have flipped that. That's now the domain. The domain of the exponential function was, we have flipped that. That's now the range. Good. With our exponential functions, we emphasize the fact that so long as the function was not translated or majorly transformed, the y-intercept was always 1. Logarithmic functions, the x-intercept is always going to be 1. Exponentials, the y-intercept is 1. Logarithmic, the x-intercept is 1. It's flipped. And then the asymptote. So like I mentioned, in the past, all I asked you to do was to graph the asymptote. Going forward, I'm going to be asking you what is the equation for the asymptote. So the asymptote before was on the x-axis, y equals 0. It's now flipped. It's on the y-axis. The equation of the asymptote is x equals 0. Logarithmic functions are another thing the graphing calculator does a terrible job at. When you look at a logarithmic function on the graphing calculator, it looks like it just kind of gets close to, in this case, x-axis, just kind of stops. If we would look at log base 2, we can't look at log base 2, but well, we can. Nah, forget it. Yeah, just to emphasize how bad it is, I'll bring it up. Did you catch from the video the fact that there is a log button on your calculator, but there is no base written on it? Okay, log button on the calculator, right down here. There is no base. Did you catch what the base is? Excellent, very good. So if I would just put in log of x. Like I said, the graphing calculator is a terrible job of this because it makes it look like it just stops right there. Now, if I would zoom in, if I'd only look at x's from like say 0 up to 1, it's maybe a teensy bit better, not much, but maybe a teensy bit better. If I'd go to the table, and I'd go up by, let's get really extreme and say hundreds. Now it'll show you, yeah, there's all kinds of y values there. Not a 0. Not a 0. It goes right up really close to 0. Never gets to 0. If I go even more extreme, I've still got y values here, but the calculator itself does a terrible job of displaying them. Questions to start? Anything we've discussed? Okay. So here's the big deal. One of the big deals. The number one big deal is understand what the logarithmic function is. The second big deal is that you need to be experts at converting between exponential form and logarithmic form. What I just circled. You need to be extremely comfortable with that before you walk into this class tomorrow. A short kind of side note, this is more of this is definitely a geometry discussion. In geometry, you discuss what are called conditional statements. This is an example of a conditional statement. So let me give you a little example. If it is raining, I will take an umbrella. If it is raining, I will take an umbrella. That's a conditional statement. If this exists, then I will do this. And does that conditional statement make sense? If it is raining, then I will take an umbrella. What if I were to flip it around? What if I were to take those two statements and flip around? If I take an umbrella, then it will be raining. No, Katie, I do not possess power over weather, right? You're exactly right. That doesn't make any sense. Katie's like, no. Yeah, that doesn't make any sense. If I take an umbrella, then it will be raining. That statement only makes sense in one direction. If it's raining, I'll take an umbrella. But if you flip it around, it makes no sense. This conditional statement says if and only if, which interestingly is often abbreviated if. And that conditional statement says this works both ways. If you have something written as log base b of y equals x, you can write it as b to the x equals y. And if you have something written b to the x equals y, then you can rewrite it as log base b of y equals x. This says you can go both ways. And tomorrow, we're going to discuss the laws for logarithms. They're all what are called biconditional statements like this. They work in both directions. So we need to be experts at going from here to here and here to here. The way I do this is with the help of one of my favorite artists, Meghan Trainor. Because Meghan Trainor, one of her first big hits was that it's all about the base. Okay? Love it, Trainor. Some of her lyrics get a little bit questionable, but I like her overall. That's honestly how I remember how to convert between logarithmic and exponential functions. It's all about the base. The base for the logarithm is the base for the exponent. It's all about the base. If you get the bases in the right spots, everything else will work out. Okay. So, examples. Rewrite each equation in exponential form. It's all about the base. So this has a base of 2. If I'm going to rewrite this in exponential form, my exponential expression will have a base of 2. Log base 2 of 16 equals 4. That'd be rewritten as 2 to the 4th equals 16. The base raised to what number equals the power? The base raised to what number equals the power? The base raised to what number equals the power? If the base is in the right spots, everything else should work out. Log base 4 of 1 equals 0. Base of 4 to the power of 0 equals 1. And notice that these are both true statements. 2 to the 4th is 16. 4 to the 1st, 4 to the 0 is 1. Take 15 seconds. Convert C and D. Convert them from logarithmic form into exponential form. Letter C. What's the base? 12. So the first is 12. Letter D, what's the base? 1/4 to the negative first equals 4. Logarithmic to exponential. Exponential to logarithmic. 5 to the second equals 25. What's the base? 5. Log base 5 of 25 equals 2. You need to be able to do these conversions with no issues before you walk in class tomorrow. Log base 10 of 0.1 equals -1. 15 seconds, do C and D. C, log base of 4 equals 2/3. Actually did that one earlier in the notes. Letter D, log base of equals -3. Working in log base 6. You're asking yourself, what do I raise 6 to get 1 over 216? Well, 6 to the third is 216. I want it moved to the bottom. Okay, then make it -3. Any concerns or questions here? So let's see who really understands. You got 30 seconds. I want to know the log base 327, the log base 416, the log base 232. This will tell you if you're really understanding the lesson or not. That was loud. Log base 327. Log base 416. Log base 232. That's it. What power do you raise 3 to get 27? What power do you raise 4 to get 16? What power do you raise 2 to get 32? That's how logarithms work. That's how the function is defined. Okay. This is a little trickier. At least it starts to get a little trickier. All right, I'll give you a minute. A, B, C, D. Do your best to evaluate each of those logarithms. Log base 464. Log base 5 of 0.2.
-1.
Very good. So 0.2 is the same as 2/10, which is the same as 1/5. And so the question is, what power do you raise 5 to move it to the bottom of the fraction? Well, that'd be -1. Good. Log base 1 to the 125. So now we're kind of asking the question in reverse. I raise 5 to the third to get 125, but that would be 1 over 125. I want to move it to the top. Make it negative. And then what is the relationship between 36 and 6? It's not half. That's the answer. What's the relationship? 6 times 6 is 36. Very good. So now go in this direction. What do I do to 36 to get 6? Square root. That's what I'm after. The relationship is you take the square root of 36 to get 6. Well, square root is what kind of exponent? 1/2. Good. Very good. So what about on the calculator? We have learned now that the calculator has a log button, and it is base 10. I hurt along with you as I complain for a minute about what we do in mathematics to people. It is a frustrating thing. If I was king of the world and I could change a few things, these are some things I would probably change. We make some areas of mathematics harder than they need to be out of either laziness or efficiency. What do I mean? You have been working with this symbol for years. And possibly for the first time this year, you learned that that symbol has always had a number up here. What number's always been up there? 2. Never discussed it, but it's always been. You learned about it when we started putting different numbers up there. Algebra 1 students, some of them get totally baffled and make all kinds of mistakes because they fail to recognize that when you have a variable like x, it has an exponent. It has an exponent of what? 1. It also has a coefficient. It has a coefficient of what? And if we would just write things like that, using exponents, combining like terms, would be a lot easier. We just expect you to know all that stuff. Well, here's the next thing to add to the list. You need to know that anytime you see the function log written, it means log base 10. It's another one of these secret little numbers on here. But we're not going to tell you. You just have to know that. And I think I can convince you of that fact. Maybe not. Well, let's try this. On your calculator, evaluate the log of 1,000. And tell me what you get. Because this is log base 10. And so this question is really asking, what power do you raise 10 to get 1,000? That would be 3. That is the first of 2 common logarithmic functions that your calculator knows. When you see the log button, that means log base 10. That is the most common logarithm function used. The other one is log base e. We have to represent this a different way. And so the way we represent log base e is with the symbol ln. And ln is referred to as the natural log. So for those of you who were here last Thursday and you're like, what is with this e number? Outside of the fact that it's in one interest formula, who cares? Well, it turns out that in the sciences especially, in finance also, but in the sciences especially, there's a lot of practical applications of the natural logarithm function. And the natural logarithm function is log base e. And that's the whole list, folks. When we talk about commonly used logarithmic functions, that's them. Log base 10, log base e. Every scientific calculator has a book. Okay. By the way, do you notice on your calculators, ln, the natural log, what's the second function of that? E to the x. That's the inverse. Natural log, e to the x. Logarithmic, exponential. When you look at the log button, what's the second function? 10 to the x. Log base 10, 10 to the x. The inverse function. That's kind of cool. They're literally inverses. Most of your calculators say second function, but some calculators will say inverse. Good. Just to emphasize the fact that these are different, real quick, on your calculator, evaluate log base 10 of 13. Thank you. Somebody else, evaluate the natural log of 13. 2.564. 5. Come on. Different bases. That's why we got different results. Right? By the way, always 3 decimal places. Always. We will never see any directions written out, any instruction that says you turn around your answer 3 decimal places. This is the next thing that you just have to know. You have to know that anytime you are dealing with logarithms, you're evaluating a logarithmic function, always round to 3 decimal places. That is the industry standard. Why 3? I don't know why 3. I'm not here to write the rules. I'm here to explain the rules. Those are the rules. Always 3 decimal places. Okay. I want you to try none of those. I want you to do these last 4. 9, 10, 11, 12. You got a couple minutes. 9, 10, 11, 12. 11 you can use a calculator, 12 you can use a calculator, 9 and 10 you can't. What's the log base 2 of 32? What power do you raise 2 to get 32? Log base 27 to 3. So what power do you raise 3 to get 27 to get 3? 1/3. That's the answer. Okay. You could look at it and say 27 is 3 to the 3rd. Well, I want to get to just 3. So how can I get to 3? 1/3. Okay. 27 to the 1/3 is 3. 1/3 is the same as saying what? Cube root. If that helps. Okay. Log of 12. Zero, 7, 9. Thank you. Natural log is 0.75. 0.3. Thank you. Domain of any untranslated logarithmic function is x is greater than 0. Very good. Range of any untranslated function is, or actually a translated function. Yep. Your syllabus has not been posted yet. That's going to take place during 4th period.